They have relations from set A to set B for case of one element in set A goes to only one element in set B. This is what we call the case of relations of one-to-one. We may have relations set A to set B. Many elements in set A goes to only one element of set B. This is what we call relations of many to one. And we may have the relations from set A to set B. Where many elements in set A go to many elements in set B. This is what we call the relations of many to many. All those four, they are relations. But when we're going to look at functions, we are going to find functions. Functions, according to the relations, the four relations, only two represent function. This is function. This is function. So function is a relation of one-to-one or many-to-one, or more precisely, we can have the definition of functions. And the definition of function a function f, one function f, is a rule that assigns to each element x in set A exactly one element, which is we call fx in set B. So the reason why this is not a function, because one element in set A goes to more than one element in set B. According to the definition of function, yes, because the definition of function there say that each element in set A goes to exactly one element in set B. Like this. Even though both of them goes to one place, does not matter as long as goes to only one. This is not a function. So you know definition of functions now. The definition of function, meaning that one element in set A goes to only or exactly one element in set B. Exactly one element in set B. Right. So when people say that what is the definition of function, now you say this is the definition of function. So you try to test that one element you substitute into A, you get one element in set B. For instance, how to evaluate one function, how to evaluate or how to find values of one function. For example, if given one function given one function is x plus 1. For example, yes, this is a function. Since one value you put in terms of x here, you get one value for fx. it will not go to more than 1. Right. So how to evaluate? Evaluate F2, for example. F2. You just put 2 in terms of x. You got 3. That's the value of the function fx equal to x plus 1 for the case when x is 2. You may ask of evaluating f 3 over x. What do you have? You substitute 3 with 3 over x. In the place of x here, you replace with 3 over x plus 1. Look, before x here, you replace with 3 over x. So in the place of x, you replace with 3 over x. So f3 over x is 3 over x plus 1. Similarly, for the case of f minus a, you substitute with minus a plus 1. You substitute in the place of x with minus a, and then minus a plus 1. But when minus of fa, meaning that you have to put a minus, you evaluate the function of fa, which is you change x to a, you get a plus 1, which is minus a minus 1. So you can see that the value of f minus a and the value of minus fa, they are different. Because in this case, we put minus first, and then we substitute the value of x with a. Right. Right. When we want to determine whether what we have represent a function or maybe represent not a function, we can test whether given one expressions it represent a function or not. Testing it, what we call algebraically test. So algebraically test, as I showed before, we test we substitute one value of x, you will get one value for y. Or you see whether it is relations of 1 to 1 or many to 1. One value for x goes to exactly one value of elements in set B. Now, that's algebraically methods of testing whether that expressions give expressions of a function. But if given in terms of graph, give a graph. We would like to know whether that graph represent the graph of functions or not represent the graph of function. So another way of testing is we say testing graphically. But testing graphically, we need to get graph. Without graph, we cannot test. We don't know. And when testing graphically, we have one test which we call vertical line test, which we called vertical line test. Vertical line test say that the graph of a set of points in a coordinate plane is the graph of function if every vertical line intersects the graph in at most one point. Or in other words, it's easy is you draw one vertical line and then you test by drag that vertical line to the left or the right to see must be always that vertical line intersect the graph at one point, at most at one point. If intersect of the graph at more than one point, that not represent a function. So must be intersect the graph at most one point. So you drag one line, one vertical line throughout the graph and you look what happened. Is that intersect at one point? If always intersect at one point, yes, that graph represent the graph of a function. If intersect at more than one point, that graph not represent the graph of a function. Simple. To know whether the graph represent a function or not represent a function, see, whether the graph represent a function or not represent the function, look at the place of they intersect. So they intersect at one point only. If more than one point, not a function. We have several types of shape of the graph. Must be intersect at only one point. Right. Okay. And now, you know now that how to know, how to test whether it is represent a function or not a function. Now, we go to how to find the domain of the function. Domain of the function. domain of the function, it's easy. It's like this. In a simple word, domain of the function is some sort that every values of x which make the function defined. Every value of the variables. Variables can be in terms of x, can be in terms of y, in terms of z. Every value of the variables can be put there. Any number can be put in the variables, make our function defined. Make our function defined. For example, we go back to the function of fx equal to x plus 1. So when we look at the functions of x equal to x plus 1, variables in this case, x. So the number which make the function defined, what are the numbers which make the function defined? That's domain of the function. If you look at those numbers, what a number can be fit there? What a number can be put there? Now, what number you think that can be substituted there?
1.
What about 2?
Two also can.
So, what can you say? What are the conclusions you can say?
Every number.
Huh?
Any number more than 0.
What about minus 1? If you say more than 0, what about minus 1?
Any number more than 1, sir.
Any number more than 1. What about 0?
Every number except -1.
Except -1. So is that -1 cannot we put there? And if you say cannot, why you cannot put -1?
You got 0.
So got 0 meaning that
No function, sir.
Yes. Because when below 0, it will become no function.
below 0?
0.
0 is a function. 0 is a function. It's still defined, but defined as a 0. So what conclusions we can say that domain of fx here in this function from minus infinity to infinity, or we can say that all real numbers. Whatever the number we can substitute, even make it 0. 0 is a defined. We only do not want 0 in our denominator. In our denominator, yes, we cannot have 0. Let's say another function. fx equal to square root of 4 plus x. What is the function? What is the domain?
More than -4.
More than -4. You only can be substitute if the value of more than -4. Okay, if we say more than -4, what happened to -5? What happened if you substitute -5? If you say more than -4,
Undefined, sir.
undefined. Why undefined? Why undefined? Yes, it is
You
undefined.
because you will get a complex number.
Right,
The I negative something.
right. So the domain of the function is from -4 until infinity. This is in interval notation. This is what we call interval notation. Domain of the function from -4. This is including. This is the meaning, the sign of including. Including here because we still can put -4. We put -4 here, meaning that 4 minus 4 is 0. And square root of 0. 0 also can. We only cannot have 0 for the case that it's denominator. In this case, we don't have denominator because this is not a fraction. Only for the case of fractions, we have denominator. Let's say we have the functions of fx 1/x. The functions of fx is 1/x. What is the domain of this function?
Every number except for 0.
Every number except 0. Every number except 0 because we cannot put 0 there. If you put 0 there, the function will be undefined. The case when 0 appear in our denominator, for this case doesn't matter because no denominator. This case also no denominator. Only that we have to make sure that instead of square root is not a negative. Right. So in interval notation, domain of fx is in interval notation. We want to write in interval notation from -infinity until 0. Exclude. Because we don't want to make 0. Union with from 0 until infinity. Meaning from this interval notation, all numbers except 0. All real numbers except 0. Right. Right. Um, let's say the function is the function of 1 over x squared minus x. What's supposed to be domain of this fx?
All number except 0 and 1.
Number which we cannot put in the function f of x is 0. Definitely 0, we cannot. And also we cannot put 1. Therefore, domain of the function f(x) is in interval notation minus infinity until 0 union with 0 until 1 union with 1 until infinity. So we have to bear in mind that 0 until 1 we have numbers there, a lot of numbers there. Perhaps you always say that from 0 after 0 on 1, between 0 and 1 we have numbers. So all the numbers here can be included as our domain. Only we need to exclude 0 and 1. Right. Domain of the function. So domain of a certain function, when given one function, domain of certain function are simple. It's like this. Whatever you can substitute into variables. Variables, not necessarily x, but we have here, for cases that we have here, all x, but sometimes written in another number and the alphabetical, does not matter. Which make that our function defined. So from previous semester, that students always confused about the domain. So I said that domain simple. You just think of like this. What make the function defined? That's in our domain. Number which make that our function undefined, we have to exclude them. So the way we write is important now, like this. And then we exclude number 0 and number 1. Here meaning that we have to exclude number 0. Here meaning that we exclude all the numbers which is less than -4. Here we do not exclude at all. All the numbers can be put. Why? Because this is our function. Right. when we say domain of function, domain of certain function, same like how to determine function. We can determine domain of the function algebraically. So algebraically, how? Like what I showed you before. What is algebraically, right? Which we have to calculate. Apart from algebraically methods of finding the domain, we can find the domain using graphically method of finding domain. Graphically methods of finding the domain, we just look at x axis. We just look at x-axis. So that x-axis represent what's supposed to be our domain. For instance, we have one function, fx equal to square root of 4 minus x squared. Determine the domain of the function graphically. Graphically, not algebraically. If algebraically, definitely we can test to be the value of x which make the function defined. But now it's graphically. So, first of all, what we have to do, we need to sketch this graph, because when we talk about graphically, definitely we want the graph. And from that graph, we can determine the domain by looking at the x-axis of that graph. Now, when we sketch the graph, x, y, we sketch the graph of square root of 4 minus x squared. Square root of 4 minus x squared. The graph of square root of 4 minus x squared. So you sketch. When x is 0, y is fx. This is fx. 2. Right. When x is 0, y is 2. When x is 1, it's square root of 3. Let's say square root of 3. When x is 2, y is 0, when x is minus 1, again square root of 3, when x is minus 2, it's 0, and then you connecting all those, right? This is the way you create graph. I think to create graph is just you substitute the value of x and the value of y. I'm sure, and I'm definitely sure that you're familiar with this. You're familiar. And when we look at this, this is the graph. This is the graph of the function for minus x squared. When we look at the graph of this function, so what can we say? What is the domain of this function? What is the domain of this function? I remember that. Now we want to determine the domain graphically. So what is the domain of this function?
-2 until 2.
Start from, see, the graph is start from -2 and then goes until 2. Therefore, domain of the function f(x) is from -2, which is including until 2, -2 until 2. That's the way how determine domain of the functions graphically. I remember that. So far that we know how to determine. First, to determine function. When we talk about relation, now we know that at the beginning of the lesson, when we talk about relations, not all the relations represent function. So we determine whether it's represent a function or not by two methods: algebraically methods or graphically methods. For graphically methods, what we know, what we have to do. What's the name of the test of graphically methods?
Vertical line. Vertical line.
Vertical line test. That's to determine whether function or not a function. Then after we know that it's a function, to determine whether what is the domain of the function can be tested using algebraically and graphically. Graphically, we look at what? We look at what? Graphically.
X exists.
X exists. Right. And remember that always when we have algebraically, we have also graphically for these two. For determine functions and also to find the domain of the function. And in the examinations test, you need to follow the instructions. Let's say find a domain using graphically methods, graph. Even though you answer correct, but by using algebraically methods, marks will not given because you do not follow the instruction. Find the domain of this function using algebraically method. Use algebraically methods. Even though maybe use graphically methods, correct. But no mark will be given because not follow the instruction. So always I say that important that you read the questions either in examination or test, you read until end, until finish. So we know that which methods we need to use. In some, we have several methods. In some cases, only one method, right? Especially when you study matrices later, trigonometry later, especially trigonometry, right? Because with the current modern calculator, some of the value we can have straight from the calculator. But if the instructions that using even odd property, you know later when you study trigonometry, using even odd or using periodic, solve that. You need to solve using that. Otherwise, no. With the modern calculator now, right? Again, bear in mind that quiz 1 will be on 9th of September, night time, 8 p.m. Quiz 1 will cover chapter 1, chapter that we already finished. Chapter consists of 3 things: equations, inequality, and complex numbers. Tutorial, I not mentioned yet the day or the date you did that you have to submit. So you just try the questions. You get the question in Google Classroom, your Google Classroom now. You can see the question of the tutorial, right? But no submissions yet. Just try. When time to come, and I will need to submit. Right. So come back at 9 o'clock. I'll break for a while. Come back at 9 o'clock. Right. Okay. given the function f(x) equal to 3 over x cubed minus 8x squared plus 15x plus 1 over x minus 4. 1 over x plus 4. I'll find the domain. Find the domain of this function. Find the domain of this function. So it consists of two parts. We have two fractions. Then either x cubed minus 8x squared plus 15x not equal to 0, and also x plus 4 not equal to 0. So how to get this from here? From here, as you get x is not equal to minus 4. From left, but how to get x cubed minus 8x squared plus 15x not equal to 0? What we have to do? What we have to do in order to make sure that it is not equal to 0? What do we have to do?
Factorize.
Factorize. So how to factor x cubed minus 8x squared plus 15x? Remember that three terms here. We have three terms here. They consist of x. So make x as common factor. The allowance is x. So in order to produce x cubed, so x must be multiplied by x squared. And then what?
Minus 8x.
Minus 8
Minus 8x
plus 15.
plus 15 not equal to 0. So from here we can say that x not equal to 0, x squared minus 8x plus 15 also not equal to 0. So x squared minus 8x plus 15 how do you get the x squared minus 8x plus 15?
X minus 5.
X minus 5,
X minus 3.
x minus 3.
Yeah.
X minus 5 and x minus 3, therefore x not equal to 5, x not equal to 3. Right. So domain of fx, which we write in terms of interval notations, is going to be what? How to write in interval notations? How to write in interval notations?
Negative infinity to 4 to negative 4, sorry.
Negative 4.
And then
Union.
negative 4, union to negative 4 to 0.
0.
Then 0 to
0,
3,
3.
3 to 5.
3 to 5.
5 to infinity.
5
Oh,
to
yeah.
infinity.
Okay.
Meaning that those numbers -4, 0, 3, 5, we have to exclude. Because by put them make our function undefined. Right. Another function. Fx equal to x squared plus 1. Given that x is located between 0 and 5. So what is the domain of this function? What is the domain of this function? Huh?
Include 0 to 1.
0 to
1.
1.
1.
5.
0 to
5.
5. It's clear that here it's from 0 to 5. Even though if not mentioned that from 0 to 5, definitely all real numbers. All number can be put in the function. Let's say fx is equal to square root of x squared minus 9. Square root of x squared minus 9. What is domain? What is domain? X square is x square minus 9. So the square root of x square minus 9. Right.
Include -2 to 2.
-2 to 2.
Sorry, -3 to 3.
-3 to 3.
Yes.
Yes. Domain of fx from -3 to 3. Or you can do, how to find the domain here is you go back to the inequality. Remember that we want whatever inside the square root, which is x squared minus 9, must be greater than or equal to 0. Positive. So, factorize x 3 minus 3 plus 3. So up till here, what we have to do? Go back to inequality. What do you have to do? Up till here. Inequality. What do you have to do?
X minus 3 equals to 0, x plus 3 equals
So
to 0.
what we say then?
Critical number.
We search for the critical number. We search for critical number, which is you have x is minus 3 and x is 3. And then minus 3, 3. This is a diagram. X minus 3, x plus 3, resulting sign. Value which is less than minus 3, minus, plus. Right. Oh, sorry, here isn't domain is not. Sorry. No. We have to look at the timetable here. You understand? You understand up to here? Sign table, we go back to inequality. Then
Negative.
Positive. Negative.
Positive.
Positive. Negative. Positive.
which one we take?
Positive.
Positive. Therefore, look at it where? Look at it where? Why we choose positive instead of negative? Why?
Because integration is more than 0.
More than 0. Then, from where to where? When we talk about negative. From where to where?
Negative infinite.
Minus infinity
To negative 3.
minus 3. Including or excluding?
Excluding.
Excluding. Why excluding?
Including.
Including. Why including?
Because we get 0.
Okay. Union.
3.
3.
Excluding infinity.
That's the domain of the functions. Right. If let's say we have function of fx equal to 1 over 3x minus 6. What is the domain of this function? What is the domain of this function?
Negative infinity to 2.
Domain of fx is minus infinity until
2.
2. Is it including or excluding?
Excluding.
Excluding. And then, if we say negative infinity until 2, what happens?
Excluding 2 to excluding infinity.
Okay. Minus infinity to union with 2 until infinity. You get it? You understand?
Yes.
Because here we can have all the numbers except number 2. Except number 2 we cannot have. Let's say we have the function of fx equal to square root of 6 square minus x square. What is the function? What is the domain of this function? What is the domain of this function?
So negative infinity to negative 6.
Negative infinity to negative 6.
And 6 to infinity.
And 6 to infinity. If you say and 6 to infinity, what happened if 7 here? Yeah, the function defined. If you put 7 or 8, it's 6 to infinity. So back, we have to go to sign tables. 6 square minus x square greater than or equal to 0. 6 x plus minus factorize 6 square minus x square greater than or equal to 0. So up till here, what do you have to find? What do you have to find?
Critical number.
Critical number. So our critical number x is
Plus minus 6.
minus 6 and plus 6. So sign diagram. Minus 6 plus 6. 6 minus x, 6 plus x, resulting sign. This is 6 minus x, 6 plus x. This is resulting sign. Take one value which is less than 6. It's going to be
Positive.
negative, right? One value greater than 6, substitute into 6 plus x. You substitute there. What do you get?
Negative.
Negative. So negative and negative, positive. And between minus 6 and 6, negative. Positive. Negative. More than 6, positive. Positive. And positive. And what we want? Which one we want? Either positive or negative?
Positive.
Positive. Why we do want positive?
More than 0.
Because sign here is greater than 0. Therefore, from here we can see that domain of the function is where? Domain of the functions.
Minus infinity.
Minus infinity,
Including
including minus 6.
Minus 6.
And union with 6, including E6 until infinity, including. So from sign diagram, we see that. As you said before, that domain is from minus infinity to minus 6 to plus 6. So from minus infinity, minus 6, minus infinity to minus 6, and union with 7, 6 until infinity. Right.
Sir,
Is that positive or negative then?
sir,
Yes?
from the equation, how can we know that
Uh-huh.
it is greater than 0?
Because we have to make sure that 6 square minus x square always must be greater than 0.
Oh. Okay, thank you, sir.
Right? Sorry, if you put... Sorry, the sign diagram is wrong here. Sign is wrong. Sign is wrong. You try again. Take one value which is less than minus 6. You substitute here. It's positive, right? Let's say you take negative 7. You substitute. So, positive. Here is negative. Negative. Here is negative. See, this, when we put different or wrong sign, it's going to be wrong. And this is negative here. This is positive. And positive. Positive there. This is positive. And...
Negative, sir.
Huh?
Um,
Negative here. A negative. Positive is going to be negative. And then we choose positive. And our positive is not this. Our positive is from minus 6 until 6. Sorry about that. So domain of fx is from minus 6 until 6. We choose positive here. Right. Right. So I have to stop here. Here, and you see it again tonight, and inshallah we'll see you back on Monday. Right.